Hello everyone. Okay, today I will be talking about Maldi Tof Ms. First, let's get to know what is the Maldi Tof Ms. Alright. First, Maldi stands for metric acetate laser desorption ionization. For TOF, it stands for time of flight, and the MS, it stands for mass spectroscopy. One of the functions of Maldi Tof Ms is to analyze biomolecules such as peptides, lipids, saccharine. Next is the components of the instrument. This is the main components of Maldi Tof mass spectroscopy, which consists of sample introduction, ion sort, mass analyzer, detector, and signal processor. This is an example of the actual machine. Next, let's talk about 5 steps of Maldi Tof Ms analyzing. Step 1. Samples are mixed with matrix, which consists of small organic molecules, which is then placed in a target metal or stainless steel plate. What is the matrix? Matrix is a small organic molecules. It helps to dilute and separate analyze a molecules from each other. And it also helps to absorb energy from laser. Step 2. Both ion sort and mass analyzer are placed under the high vacuum system. But why we need a vacuum? Because it's important that the ion produced in the ionization chamber have a free run through the machine without heating air molecules. The third step, the ion sort is Maldi. Maldi involves the use of matrix and laser. The chosen matrix should be polar for polar analyze and the non-polar for non-polar analyze. Working principles of Maldi is that the laser beams such as nitrogen gas UV laser, which is the ion sort with wavelength around 237 nanometer, is bombarded into the matrix. Hydronium ion is transferred from the matrix molecules to the ionized, resulting in ionization. As a result of using Maldi, which is a soft ion sort, the samples are not destroyed, so there would be little fragmentation. And parent peak is obtained, which provide information about the molecular mass. Step 4. High voltage is applied to accelerate the generated ions. Step 5. Ion then travel to the mass analyzer. In this case, it is a TOF. Ions of the different mass overcharge travel along a filtered drip tube by the applied electric field with constant kinetic energy. Therefore, ions with a small mass overcharge volume are the lightest, so it reaches the detector first and appears on the mass spectrum. After that will be the readout. The spectrum will be consist of mass per charge ratio on the x-axis and relative abundance on the y-axis as shown in the picture. This is an example of spectrum of a mixture of proteins. This analyzing technique is really useful for the qualitative analysis. By observing the peaks provide information of molecule mass of the molecule. Ions can be accurately identified by ratio and reading on the spectrum represented in the constituent. Next is an application. First application is lipid analysis, and this is the examples of the spectrum. The second one is the peptide mass fingerprinting. This is the method used to identify proteins from sample mixture, which is used with two-dimensional gel electrophoresis. Peptides are generated by digesting proteins of interest. The experimental mass are compared with the database containing theoretical peptide mass. Multi-imaging MS is used in the profiling and imaging proteins, providing specific information, and analyze multiple unknown compounds. And it can also analyze multiple unknown compounds in the thin tissue. Next would be the pros and cons. And the pros are, it can detect and characterize organic molecules, raw synthesis polymer and biopolymer. Since this is a soft sort technique, the sample will not be destroyed and show very little fragmentation. It produces simply short ions, distinct and accurate spectrums. For the cons, Maldi Tof is a strong analyzer, so cost effective. Multi-cluster ions is at least than 600 mass per charge species. Signal reproducibility is low. Difficulty coupling Maldi with the chromatography